Hello and welcome back to Everything Boats with Captain Frank Lanier, where we discuss boats and boating, from maintenance and repairs to seamanship and safety, as well as everything in between. This podcast is a companion to my YouTube channel of the same name, so if you like and find it useful, be sure to subscribe and please check out my YouTube channel as well, where you'll find hundreds of informative videos on pretty much every boating topic imaginable. So today we're going to be talking about engine mounts, the Rodney Dangerfield of your engine compartment, in that they just don't get no respect until failure. Even after that odd noise or excessive vibration is noted, chances are they still won't get any attention or the respect they need until catastrophic failure. As it never pays to use equipment failure as an indicator that required maintenance is past due, we're going to discuss not only how to inspect your engine mounts for possible issues, but also things you need to consider should you have to replace them. First up, let's start with a little primer on exactly what your engine mounts are supposed to do. The purpose of the engine mount is to isolate the vibration generated by the engine, as well as isolate and protect the engine from externally generated shock loads or vibration during vessel operation. Properly functioned engine mounts are critical, both to prevent engine damage and improve the comfort of those on board who would otherwise be subjected to constant engine-generated vibration during operation. So now that we know what your engine mounts are supposed to do, let's talk about engine mount construction. A generic description of an engine mount would be a mounting stud, sometimes two, embedded in a block of elastomer, typically natural rubber, neoprene, EPDM, or silicone, that's bolted between the engine and engine mounting bed via metal plates. This design and combination of materials allows limited movement between the engine and the bed while absorbing vibration and minimizing shock loads that could cause damage. Engine mounts must be designed to handle everyday issues such as chafe and corrosion, while possessing high fracture toughness to protect against unnatural stress, which gives rather than them being bent or misaligned. So the next question you may ask yourself is, what's the service life for my engine mounts? The manufacturers are all over the board on this one, with service life expectations ranging from 1,000 engine hours, 4 years, 7 years, 10 years, or even multiple decades. It depends on the engine mount you get, and what you would want to do is to verify what the manufacturer states their service life is for their engine mounts when you purchase them or when you're looking to purchase them. As with many onboard maintenance items, factors such as how often you operate the boat, the conditions you operate it in, and how hard you drive the boat, particularly in rough seas, will all affect the lifespan of your engine mounts. The bottom line is that you'll not only want to follow the manufacturer's guidelines, but your own observations and inspections as well. Regardless of projected lifespan, one thing that's for certain is failure to replace your damaged engine mounts can result not only in engine damage and reduction gear failure due to misalignment issues, but also shaft damage due to twisting. Damage to the vessel itself can also occur if the engine is not mounted securely, as may be the case if the mount fails. So now let's talk about warning signs and symptoms of a failed or failing engine mount. These include the following: unusual or excessive movement when starting or stopping the engine. A worn or damaged engine mount may seem okay during engine operation due to the stabilization effect caused by constant torque. However, excessive engine movement when starting or shutting off your engine is a possible indicator of engine mount failures or issues. Increased vibration or unusual noise when the engine is started or while at idle are common signs of faulty engine mounts. The anti-vibration properties of the damaged mount are reduced, resulting in more noise and vibration. Visual cues include physical problems such as cracks, separation, corrosion, permanent deformation, and outright failure such as broken stud or frame, all of which are signs of engine mount failure. Another is excessive movement during vessel operation, particularly in rough weather. A damaged engine mount that gives little indication of failure in general may show its true condition during the engine acceleration and while cruising at higher RPMs. Excessive noise, increased vibration, even impact sounds or damage where the engine strikes something around it due to excessive movement are all telltale signs of one or more damaged engine mounts. In such cases, you may discover that gravity is the main force keeping the engine in place. So let's talk about inspections. First step in checking your engine mounts, simply looking at them. Does the engine mount look serviceable, Or is there corrosion or obviously damaged components? Does the engine bracket sag or rest too far down on the mount stud? A typical indication that the elastomer material has lost its elasticity. I discussed the topic of engine mounts and inspections with a good friend of mine, Chris Diggs. He's an excellent mechanic and owner of Diggs Diesel, located in Hayes, Virginia. And he gave me the following insight. And I'm going to read them verbatim here so I don't mess up his quotes here. Engine mount inspection is mainly visual. Look for corrosion where the rubber meets the aluminum or steel in the mount. Also look for any cracking in the rubber, which will diminish the amount of weight a mount can hold. This will cause the engine to drop slightly and then become out of alignment with the running gear. The jacking nuts should also be free of corrosion and lubed for easy movement during alignment. If the nuts will not move freely, the mount should be replaced. You do not want the mount in a torsional bind when aligning the engine, which should sit down straight on the mount. Okay, so that's in the quote for Chris right now. So next, let's check the mounting bolts for looseness. One trick to spot the loose or broken mounting hardware is checking to see if there's grime or residue on the engine bed around the base of the engine mount has been disturbed due to movement of the mount. Depending on the installation, you may even see fiberglass dust, a result of mount movement along the fiberglass engine bed. Is the elastomer material cracked, cut, or does it show signs of delamination or separation where bonded to the metal? Is the elastomer material swollen or sticky, or showing other signs of deterioration due to age or possible contamination from engine fluid such as oil and coolant leaking on the mount? To inspect the elastomer to metal bond failure, gently insert a thin feeler gauge between the two and note the measurement. If you can insert the gauge greater than 3 to 4 millimeters, the mount should be replaced. While you're at it, check the metal components of the mount itself for signs of fatigue or mechanical failure, such as cracks, gouges, loose bolts, or plate deformation. Another option, depending on the installation and engine size, might be to use a pry bar to lift the engine slightly while checking for separated or broken mounts. And I'll quote another little thing here from Chris, but from our conversation, and he says this method works on gas and smaller diesel engines installed in sailboats, but for larger diesel engines, it's hard to get enough leverage in most engine rooms to really move it effectively. He goes on to say that fortunately, you can get similar results by observing the mounts during vessel operation. One running test I always do is a back down test, and this will torque the engine in the opposite direction from forward, where most engines run at speed. When you put the vessel in reverse and rev the engine to 1200 to 1500 RPMs, he says, the mount should hold the engine tight with minimal movement. One of the most difficult things to spot is a broken engine mount stud. A broken stud is difficult to spot during a visual inspection, but conducting a back down test and watching for engine movement will help spot them. This is the best way to stress test engine mounts and fully inspect their condition. Okay, so let's close with talking about engine mount replacement tips. These are things you need to consider if you have to replace an engine mount. Number one, engine mounts are rated based on engine weight and output power. If you're repowering, the engine manufacturer will provide the appropriate mounts for your new engine. Number two, when choosing new engine mounts, match the size of the mounting hole in the casting to the bolts that are driven into the bearing or stringer. You also have to determine the correct stud size for your engine's brackets. Number three, if one mount fails, replace the other three as well, as they're likely the same age and similarly prone to failure. You also want consistent elasticity in the elastomer of each mount. Wow, so I tried to say that 3 times fast. 4, choose engine mounts that feature fluid and heat-resistant elastomeric polymer and are constructed of a material that will last in the environment where your boat is located. Stamped steel mount bases may do okay in fresh water, but cast aluminum will last a lot longer in salt water. I hope you enjoyed today's podcast. And if so, and you want to buy Captain Frank a cup of coffee, please click on the support link in the text description below. All monies received, not spent on coffee, will go towards making even more awesome podcasts for my channel. And as always, thank you for your support.